Welcome to The Explainer, where we crack open complex topics by looking right at the source material. Today, we are diving deep into the engine room of the Bitcoin network. We're going to use the original blueprints to really understand how a system with no one in charge can possibly work. So, right off the bat, here's the central mystery that trips everyone up. If there's no main computer, no central server, who's actually in charge here? I mean, think about it, a global network with no CEO, no headquarters, and no single point of failure. How does it manage to agree on anything, let alone stay secure? Honestly, it sounds like a recipe for disaster, but it works. And today, we're going to find out how. Okay, here's our roadmap for this explainer. First, we'll get a bird's eye view of Bitcoin's digital ecosystem. Then, we'll meet the key players, the network's inhabitants. After that, we'll see how a newcomer joins the party, how information zips around, and finally, how the whole thing protects itself. First up, let's talk about the ecosystem. We're going to map out what this network without a center actually looks like. So, the entire foundation is built on this idea of a peer-to-peer network, or P2P for short. If you were around for the early days of file sharing, you know exactly what this is. There's no big central hub that controls everything. Instead, every computer, every peer, just talks directly to the others it knows. It's a flat, democratic structure. Now, it's not just a totally random jumble of connections. There is a kind of structure to it. You can almost picture it like this, with a series of layers, kind of like ripples in a pond. These layers help define how all the different computers, or what we call nodes, connect and chat with each other. So, right at the core, you've got the reachable network. Think of these guys as the public squares of the network. They're always open, always listening, ready for new connections. Wrapped around that is the non-reachable network. These are more like private homes behind a firewall. They can make calls out, but you can't just randomly knock on their door. And then the extended network is basically everything else that plugs into the system, like exchanges, wallets, and blockchain explorers. So who actually lives in this digital city? What jobs do they have? Let's take a closer look at the different types of computers, these nodes that make the whole thing hum. This chart here might look a little intimidating at first, but what's really cool about it is that it shows us that a single computer on the network isn't just one thing. It can actually wear a bunch of different hats at the same time. Its role is really defined by what it knows, what it does, and how it communicates. But to keep things simple, let's just focus on the four biggest players. You've got the miners, right? They're the heavy lifters, creating and validating new blocks. Then you have wallets, which is what most of us use to send and receive Bitcoin. You've got the full nodes. Think of them as the network's historians, keeping a full copy of every transaction ever made. And finally, the listening peers, who are like the friendly greeters, helping new nodes get connected. Okay, so that brings up a really good question. If there's no central sign-up page, no directory, how does a brand new computer join this decentralized club and find anybody to talk to? Well, it's actually a really clever three-step dance. First, the new node consults a built-in address book of trusted contacts called DNS seeders. You can think of them as the network's matchmakers. These seeders give the newbie a list of active participants. From there, the new node reaches out, connects to a handful of them, and then immediately starts asking, hey, who else do you know? And this isn't a one-time thing. Nodes are constantly gossiping, sharing lists of other nodes they've met. It's basically a digital rumor mill, but for contact information. This ensures that any newcomer gets plugged into the wider network super fast, and everyone's map of who's out there stays up to date. Okay, so now we're all connected. But how does the really important information, we're talking new transactions and newly mined blocks, actually travel across this massive, tangled web of computers? The network basically has two kinds of news to spread, and it treats them very differently. You have transactions, which are like constant, low-level background chatter. They happen all the time, and anyone can create one. But then you have blocks, and blocks are like a major town announcement. They're rare, they're super important, and they only come from one source, the miners. What's so smart about this system is that nodes don't just scream information at each other. It's way more polite and efficient. A node will first just announce, hey, I have a new transaction. Its neighbors will check their own records, and if they don't have it, they'll say, okay, cool, send it over. This simple little back and forth prevents the network from being totally flooded with duplicate information. Spreading a new block works the exact same way. Announce, request, send. But with blocks, the stakes are way, way higher. A new block is the next page in the official history book of Bitcoin. So as soon as a node gets it and confirms it's legit, it passes the news on to its neighbors, and that announcement ripples through the entire network incredibly quickly. And this image right here shows you exactly why that speed is so critical. If two miners find a new block at almost the same time, you can get a temporary split or what's called a fork. For a little while, different parts of the world have two competing versions of the truth. These forks usually sort themselves out pretty fast, but it really highlights just how vital that quick communication is. Which brings us to our final piece of the puzzle. With no central police force, no moderator, no one in charge, how on earth does this network protect itself from spam, from attackers, and from just plain old bad behavior? Well, the network actually has this really clever multi-layered defense system. To stop someone from flooding the network with junk transactions, it uses fees. To stop them from creating fake blocks, it relies on proof of work, which basically just means it's incredibly difficult and expensive to create a valid block in the first place. And for nodes that just don't play by the rules, there's a penalty system that'll eventually just get them kicked off the network. So when you boil it all down, the Bitcoin network is really a story about trade-offs. It gets this unbelievable reliability and security because everybody has a copy of the history. But that comes at a huge cost in terms of efficiency and speed. And what's crucial to understand is that these aren't bugs in the system. They are very deliberate design choices that put security and decentralization above everything else. And that core trade-off leaves us with a final question to chew on. In a world that demands instant everything, that values speed above all else, is Bitcoin's slow, careful, and redundant design a feature that will guarantee its long-term survival, or is it a fatal flaw that will ultimately limit its future? The answer to that is still being written.